This is part 3, I think, of our video on graphing linear relations. So in the previous questions, we have looked at graphing some linear relations. We looked at the initial value, where it was on the graph. We looked at the rate of change and where that was on the graph. So we said initial value is where it crosses the y-axis. Right? And then the rate of change is how we get from one point to the next. I'm just writing how to get to next point. So we'll start with graph A. We'll take a look at the initial value. That's usually the easier one to find. And then we'll try to figure out the rate of change, and then we'll write our equation. Okay, so on this graph, I don't really have any axis labels, so I don't know what any of this represents. I'm just assuming it's x and y. The initial value is where my line crosses the y-axis, and it crosses the y-axis at 30. So that's my initial value. My initial value is here at 30. So at the bottom, I'm going to write that my initial value is 30. Now, rate of change on a graph is how we get from one point to the next, right? Now, I want to try to pick clear points that I can actually read off and not ones that are in the middle of a square. So if I'm taking a look at the points on this graph, my initial value is at 30. That's a pretty clear point. And then as I follow the line, I'm in the middle of a grid. I'm in the middle of the grid. Ooh, I think there's a point here. And then if I keep going, we're in the middle of a grid line. We're in the middle of a grid line. I feel like that's a good spot there. We're looking for where it hits the corner of some grid lines. And then if I go up a little bit more, that's in the middle of a line. That's in the middle of a line. That's on a corner. So I picked out some points that I feel like I can read off reasonably easily. And I'm going to look to see how am I getting from one point to the next. So I am going 1, 2, 3 squares up and 1 square over to get from my initial value to that first point. Now, I need to think about the scale. I need to think about how much that is because it's not just 3. If I'm looking at the scale here, this is 10, this is 0. There are 2 squares. So 10 divided by 2 is 5. So I think we're going up by 5s. I think this is 5, 10, 15, 20, 25, 30. So this, if it's 3 squares, we're going up 5, 10, 15. So I went up 15. And then on the x-axis, we only went over 1, right? These numbers are my delta y and my delta x. On the up and down part, that's y, that's delta y. And on the side-to-side part, that's my delta x. So when I go to calculate my rate of change and I want to do delta y over delta x, my delta y is 15. I went up 3 squares, but there was a scale there. So I actually went up 15 units. So we went up 15 and then we went over 1. 15 over 1 is just 15. So my rate of change is 15. And it's always a good idea to just check and make sure that it continues following that pattern, that I didn't pick a point that wasn't really a point, right? I would go up another 5, 10, 15 over 1, 5, 10, 15 over 1, and I'm still on the line, so I'm feeling good about that. So my equation is going to be y equals my initial value, that's 30, and then plus my rate of change, which is 15, and then times x. So it's going to be y equals 30 plus 15x. We start at 30 on the y-axis, and then we go up 15 and over 1 every single time we're finding a point. Okay. Now we're going to try the next one. Same idea, slightly different graph. So initial value is where it crosses the y-axis, and it currently crosses the y-axis at 10. So my initial value is 10. And then my rate of change is delta y over delta x. So what I need to do is find more points on the line. So my initial value is good. This does not look like it's on the corner of a grid line. It's really close, but it's not quite there. That's not on a grid line. That's not, that's a little off. I kind of think it's right there, right? If I had thought that it was here, it's always a good idea to see if you can follow that pattern, right? If I thought it was one square up and one square over, try again, one square up, one square over, one square up, one square over. Are you still on the line? If the answer is no, that wasn't the right pattern. So I'm thinking it is 1, 2, 3, 4, 5, 6 squares up, 1, 2, 3, 4, 5 squares over. So I'm going to see if I can do that again. 1, 2, 3, 4, 5, 6 squares up, 1, 2, 3, 4, 5 over, and I am still on the line, so I'm feeling like we've got good points here. Okay, so I am going to count how far up, how far over did we go? All right, the scale is the same as last time. Every square here is 5. So I went 5, 10, 15, 20, 25, 30. So I went up 30, and then each one here is 1. So 1, 2, 3, 4, 5. So I went 30 up and 5 over. All right, so for my rate of change, this is the y-axis, so this is delta y. This is the x-axis, so that's delta x. So we're going to do 30 divided by 5. 30 divided by 5 is 6. So my rate of change is 6, which is why it was close here, right? It looked like it was up 5 over 1, but it was a little off. So it makes sense that it's up 6 because that would have been pretty close, and then over 1. All right, then for my equation, y equals my initial value of 10 plus my rate of change of 6, and then times x. Okay, so the remainder of the package is homework if you don't get it done during the period. Okay, and then I will hopefully see you back in class tomorrow. Have a great rest of your day.